Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
Good afternoon, all. Good afternoon, Varun sir.
Yeah,
Sir, you can start the sessions.
right. So let us start our discussion. Yeah, good afternoon. So if you remember yesterday, I'll show you what is it we have done so far. So yesterday we have tried to explore our data. So we have started with our EDA, exploratory data analysis we have discussed. We have started working on our data. So we applied descriptive statistics, concepts we have applied, and then we have talked about numerical methods, graphical methods we have used. So under numerical methods, we have used your concepts like a describe function, info function. You are able to find out what is the mean, median for different columns in your data set. In graphical methods, you are able to create visualizations. So box plots, count plots for different columns, bar plots. So these kind of visualizations we have created. And then if you observe, we started importing our libraries and all. That was the first step. So we ran this cell, pandas, numpy, cbon, matplot, lib.pyplot, these steps. And then we imported our logistic regression from sklearn library. We started reading our data sets and all. Okay, these commands we executed. Checking for our null values, payments.isNull.sum. Describe functions. Okay, then creating our box plots using cbon library. Then dropping our column case number. Then count plot. Okay, so we have seen more observations were belonging to zero category, where zero means yes. These observations are going to consult a lawyer. And then cross tab, we were able to compare these columns and all. Attorney column, insurance column, we were able to compare. And then bar plots. So the same information we were able to represent using bar plots. So similarly, for seat belt also we have created count plot. So you can observe most of the customers who are wearing seat belt. So we can say yes, they were wearing seat belt. So now I can say plt.figure. Okay, and then I can give something like this. You can adjust the size of your visualization. So plt.figure. And then I can give fixed size. So you can mention what should be the length of your image, what should be the breadth of your image, you can height and width of your image, you can decide and you can mention. So accordingly, it is going to adjust the size of your visualization. So I can change this to 5, 5. So like this, you can adjust the size of your visualization. So count plots on different columns, insurance column. So if you don't want to see these things and all, we can give plt.show. Okay, so you are not going to see these things. Okay, these things are gone. So coding and all, it is not that difficult, because whenever you are getting any errors and all, you can just copy that error, you can put it in Google and you can fix that. Okay, you can use websites like Stack Overflow for fixing your errors, or you can use your AI models like ChatGPT or Gemini models, and then you can fix the code. So whenever we are getting some errors and all during our work, so take the help of these tools and we can fix them. Similarly, we have created a bar plot comparing the seat belt column and insurance. If you observe, most of them are wearing seat belt, are customers, and then most of them, they have insurance. Now, similarly, if you observe gender column, so claim and sex column, if you see, so most of your observations are 1 in your data set. So 0 means male, 1 means female. So most of our observations are female. So this information we are able to get. Now, similarly, you can compare the other two columns, claimant sex and claimant insurance column. So most of them, if you see, they are female observations, and then they are also having insurance. So we can run this code, shift and enter. So to run any command in your Google Colab notebooks, you can press shift and enter. Or you can give control and anything is fine. Shift and enter or control and enter. So running those commands. So make sure when you're running those commands, you have your data set uploaded here. Now, if you remember, we have null value in our data set. null values are there. So I can check what are the null values in different columns. So attorney column, if you see, we don't have any null values. Then claimant 6 column, I have 12 null values. Gender column. Then claimant insurance, I have 41 null values. Seat belt, I have 48 null values. Claimant age, 189 null values. So what we have discussed yesterday is you can apply something called as imputation on your null values. So imputation means replacing the null value. So for example, if I take one column, so I have 1, 2, 3 null values. So these are numerical values in our column. So what I can do, I can take the mean of these values. 1 plus 2 plus 3 by 3. So 6 by 3, 2. Then what I can do, I can replace this null value with the mean value. So this technique, what we are applying is called as mean imputation technique. What we have applied is called as mean imputation technique. So my new data will look like this. 1, 2, 3, 2. So null value, I've managed to replace it with this mean value. So whenever you are working on numerical columns, I can apply either mean or median imputation technique on numerical columns. I can apply either mean or median imputation. And then whenever I'm working with my categorical columns, then I can use my mode imputation. So because categorical columns, you can have like gender column if you take. So claimant 6 column if you take. Most of them are female observations. Then if I have like this, male, female, female, and if I have a null value, then what I can do, I can take the mode of this column. So mode is most frequently occurring value. So we have 2 female observations. So mode will be female. So what I can do, I can apply mode imputation technique. So male, female, female, and female. So I've replaced my null value with mode value of that column, which is female. So this is called as mode imputation technique. So whenever you are working on numerical columns, you can apply mean, median imputation technique. Whenever you are working on your categorical columns, you can apply mode imputation technique. So that is what we are going to do. So if you see in Python, what I can do is fill NA function I can use. So I can say claimants. Okay, this is my data frame. Now select the column. For example, claimant 6 column. And then on this column, I want to fill by null values. So fill NA function I'm using for filling my null values. So claimant sex column, we know most of them are female observations. So female means 1. So therefore, I can replace your null values with 1. And then we are saying in place is equal to true. So what is the purpose of in place is equal to true? Is we are saying that after filling the null values with 1, your data set is going to be modified. So therefore, you give me that modified data set. We are saying return that modified data. So that is the idea. So claimant sex is a categorical column. We are applying mode imputation technique. Fill the null value with 1. That is what we are doing here. And then claimant insurance card. So claimant insurance column, if you see again, it is a categorical column. Again, 1 and 0 it is having. So we can find out what is the mode. Most of them are having insurance. So fill your null value with 1. Again, we are filling the null value with 1. And then again, seat belt card. So seat belt card mode, if you see, mode is 0. That means 0 means most of our observations or customers, they are wearing seat belt. So what I can say, claimants, I can say, and then I can give seat belt dot fill NA in bracket 0 in place is equal to. So I can write like this. So replacing the null value with 0 with the mode value. So all the categorical columns, if you observe, we have managed to replace the null values. Now, we also have claimant age. So this is a numerical column that we have to work with. So in this numerical column, we can use either mean or mid imputation technique, median I can use. So for the sake of explanation, I'm using mean imputation technique. So find out the mean for your age column, 28.41. So average age, we are getting it as 28 for our observations. So then what I'm going to do, I'm going to replace the null value in my claimant age column with your 28.4. With the average age value, I'm going to replace. Replace null values with average age value. So fill NA 28.414. Now when I run this, so all these numerical columns and categorical columns, what we have done, we have managed to replace the null values, fill the null values with either mean value or mode value. So now if I again check, if I have any null values or the claimants dot is null dot sum. So again we are checking for null values. So what we can observe, the null values have been replaced. So none of the columns columns have null. So this is what we are able to understand. None of these columns have null values. Now, so I think once we finish off our sessions and all, then I think you are going to have your exams and all. So that information will be shared by my team. They will update you on when you can give the exams and all. Now, the next step is we have to start working on our model, on our machine learning model. We have to start working on that. So let us try and understand. So from sklearn library, we are going to use our logistic regression model. This is one machine learning model. And you can use this model for solving your classification problem. So like this, many different models are there for us that you can use for solving these kind of classification problems. You can use logistic regression, decision tree models, random forest models. You can use neural network models, okay, support vector machines. Like these different models are there, what we can use. And then we can find out which of these models are working well on our data set. So for now, we are going to start with one model, one concept. We'll try to understand how it is working on this data set. So what we are doing first is we are dividing our data into X and Y. So because if you observe, I can write down the equation of my regression model like this. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 like this. So these are all my independent variables that I have. x1, x2, x3, x4 like this. And this is my target variable. So what is my task here? Using my independent variables, I am supposed to predict my target variable. And then after prediction, I have to substitute that value in this equation, in this logistic function. So whatever y value I'm predicting from here, I have to substitute it here in this logistic function. When I substitute it, it is going to give me the probability value. Because I have to predict probability values, I have to predict either 1 or 0. So that is what we are supposed to do. We have to predict either 1 or 0. So now first, what is our task? We are dividing our data into X and Y. So these are all our independent variables. Now, how am I writing this code? So claimants dot ilog. So I'm saying claimants is my data frame, claimants dot ilog, and then in brackets I'm giving 2 colons. So these are indicating rows. I want to select all the rows, and what are the columns that you want to select? Column 1, column 2, 3, 4, 5, like claimants.ilog. Now similarly, this is my X. My Y is going to be claimants.ilog and then 0th column. Because in Python, everything will start from 0. So 0th rows, 0th columns and all. So my 0th column is, if you scroll up, it is attorney column. So this is column 0 that we are working with. Column 1, 2, 3, 4, 5. So these are all my independent variables, and this is my target variable. So that is a lot. Now, so that is the first thing what we are doing. And then we are initializing our logistic regression model. So we are saying classifier is equal to logistic regression. So initializing, we are starting our logistic regression model. And then we can say fit. So classifier dot fit x comma y. So we are fitting this model on x comma y. Now, once we have fitted our model, fitting means applying our model. So applying our model we have done on our data x comma y. Okay, so you have to be careful when you are giving this. You can give only x comma y. If you give y comma x, it is going to throw some error. So remember the order what we are giving, classifier dot fit x comma y. And now once you have fitted your model, you want to know what are your coefficient values you want to know. So beta 1, what is the value? Beta 2, what is the value? Beta 3, what is the value? Beta 4, what is the value you want to understand? So 5 independent variables are there. And you are able to see what are these values in your equation. So beta 1 is 0.317. Beta 2 is 0.505. Beta 3 is minus 0.52. Beta 4 is 0.0066. Beta 5 is minus 0.322. Like this, you are able to get different coefficients. Now, next thing what I can do, I can say classifier dot predict underscore probability. So when I give like this, now we want to find out what are the predicted probability values. That means for these inputs, okay, it is going to, the model is going to make some predictions. Model is going to predict some probability values. So that probability value is going to lie between 0 and 1. That we know in mathematics, whatever probability value it is going to predict, it is going to lie between 0 and 1. So it has made these predictions. So this is for 0, this is for 1. So what you can understand, for the 0th observation, it is predicting 0.99 for 0 category, and it is predicting a very small value, 2 into 10 power minus 5 for 1. So that means it is saying there is a 99% chance that this observation is going to consult a lawyer. So 99% chance that this observation is going to consult a lawyer. Similarly, if you see these probability values, if you look at it, what we can understand is there is a 49% chance that this person is going to consult a lawyer and 51% chance that this person is not going to consult a lawyer. So my final prediction in this case will be 1. Final prediction will be 1 because more probability for 1 is what the model is predicting. So in this situation, if you observe, more probability for 0. This is what we are able to understand. So based on whichever category is having higher probability value, the model is going to decide that category as the final prediction. So how can we finally predict our values based on probabilities? So we can say classifier dot predict on my X. So these are all my predicted values. So I'm storing all my predicted values in this variable. So this is my model what I've done. So model dot predict. I can also write it like model dot predict is equal to y underscore predicted value. Now if I want to show them in our data frame, then what I can do, I can say claimants. I want to create a new column like this. And then I can say this column can have your y underscore predicted values. So all these values will be stored here. So all my predicted values I'm able to store in that column. So now if you observe, so what is the error that we are getting? Classifier is not defined. So first define your classifier. And then let us find out our coefficient values. Probability values. And now if you observe, we have made our predictions. So 0th observation, this person is going to consult the lawyer. This first observation is not going to consult a lawyer. So we are able to make predictions from our model for all our observations. That is what we have done. Now next thing what I'm doing, if I also want to see what are the predicted values and probability values together. So what I'm doing, I'm concatenating. So first I created a data frame for all my probability values. So create a data frame for all your probability values. And then what we are saying is concatenate this probability value with our claimants data. So concatenate this claimants data frame with our probability data frame what we have created. And I'm saying axis is equal to 1. What is the reason for saying axis is equal to 1? Because we want to do column-wise concatenation. Concatenation means combining simply. So column-wise, we want to concatenate. We want to combine. So this is one column, this is another column. Column-wise, we want to combine them. So what is the advantage when I combine column-wise? The advantage is, based on the probability value now, I can understand higher probability value for 0. That means final prediction will be 0. So higher probability for 0, that means final prediction will be 0. Now, so predictions we have got. Now what I can do, I can compare these predicted values. These are all my predicted values. I can compare with my actual value. I can compare the predicted value with actual value. So this will give me information about how good is my model that I have developed. This information I'm going to get how good is my model. So for comparison, there is one concept which is called as confusion matrix. So for any classification model, you can use it. For any classification model, it can be logistic regression, decision tree, it can be random forest, it can be neural networks, support vector machine, whatever model you are building, you can use this concept of confusion matrix. So confusion matrix will help us compare your actual values with your predicted value. So this is how your confusion matrix is going to look like. So imagine 0 is my negative class. Okay, 1 is my positive class. Okay, this can be my actual values, this can be my predicted values. So now, how many times your model is correctly predicting 0 as 0? This is true negative. So how many times my model is correctly predicting 0 as 0? I can call that as true negative. How many times your model is correctly predicting 1 as 1? This is called as true positive predictions. So 1 is your actual value. Your model is also predicting that is 1. So these predictions are called as true positive predictions. Actual value is 0. Your model is also predicting, your model is also identifying it as 0. So these are called as true negative predictions. What your model is able to understand correctly. Now, if you observe, how can I find out accuracy? Accuracy I can find out like Tn plus Tp divided by all your observations. Tn plus Tp plus Fp plus Fl. So we have to understand now what is Fp and Fn. So actual value is 0, but your model is predicting as 1. That means this is false positive. It is predicting as positive, but it is false. It is actually 0. This is false negative. That means actually the value is 1, but your model is predicting 0. That means it is false negative. It is predicting negative, but that is false. So that is the understanding what is supposed to happen. Now, this logic we are going to apply. So we can say from sklearn library, dot matrix import confusion matrix. This ready-made function we are importing. Import confusion underscore matrix. So we are able to apply this concept. To confusion matrix, I'm applying on my actual values, I'm applying on my predicted values. So now you can clearly observe that you got your 4 values. So if you observe, you have 0 and 1. This is 0 and 1. So what you are able to understand, 0 has been correctly predicted as 0, 435 times. Okay. Then 1 has been correctly predicted as 1, 508 times. So I know this is true negative, this is true positive. True negative and true positive. So what I can do, I can find out the accuracy. True negative plus true positive divided by all these observations. 1340 observations. So I can find out my accuracy like this. 508 plus 435 divided by 1340. Five zero eight plus 435 divided by 1340. This is going to give you the accuracy. So for our logistic regression model that we have developed, we are able to compare our actual values with predicted values, and we are able to create this confusion matrix. From this confusion matrix, what is that we are able to understand what is true positive, what is true negative, and we are able to add those values and divide by total number of observations. This is what we are able to do. Now, if we observe, the same thing we are doing here. So we have the summation of, we are trying to compare actual values with your predicted values. So wherever my actual value y is equal to predicted value. So I'm checking for this. Wherever this condition is satisfied, take the sum of all those values, take the sum of all those conditions where this is being satisfied, and then divide it by total number of observations. So when I say claimants dot shape, you are going to get 1340 cross 6. That means you have 1340 rows and you have 6 columns. 1340 rows are there, 6 columns are there. So when I say claimants dot shape 0, it is going to pull out this value, 1340. So effectively you are doing this. 435 plus 508 divided by 1340. So now remember one thing. If you observe carefully, what I have done here is, first I have given actual value here, second I have given predicted value. So accordingly, you will have actual values here, you will have predicted values here. Confusion matrix. And this is 0, this is 1. Now same confusion matrix I can also create using my cross tab. So yesterday we have seen pandas.cross tab we have applied to compare two columns. So I'm comparing two columns, y underscore predict and y. So here first I'm giving y underscore predicted, next I'm giving y. So on your rows you are going to have predicted values, on your columns you are going to have actual value. So predicted value, actual value. So how can we understand this? So we can say actual value is 0, predicted value is 0. So 435 times your model is getting correct. Then actual value is 1, predicted value is 1, your model is getting 508 times. But actual value is 0, predicted value is 1. That means this is false positive, this is false negative. So you can write down like this. So true negative 435, then true positive 508, then false positive 147, false negative 250. So these measurements we have calculated. So now when you try to find out the accuracy for our model, so what is the value that we are getting? 70%, 70.3%. This is the accuracy of our model. So far, what is that we have done? We have built our logistic regression model. We have clearly defined what is X, what is Y. We have initialized our logistic regression model. Then classifier.fit, we have said X comma Y. And then we wanted to find out what are the predicted probability values. Then we are saying classifier.predict underscore probability X. And then we want to find out the final prediction. So classifier.predict X, we are saying we got our Y underscore predicted values. So we have actual Y values and we have predicted values. Actual Y value you have, predicted Y value. Now you are comparing. So we are comparing actual value and predicted value. We are comparing. And this comparison we are able to do using your concept of confusion matrix. So confusion matrix is going to look like this. These are your predicted values. These are your actual values. 0, 1, 0, 1. This is your true negative. This is your true positive. False positive, false negative. So from this matrix, we are able to find out your accuracy. Now, Along with accuracy, you can also find out some other measurements for our model. We can find out some more measurements. What are those measurements? We can find out how good is our model. Yeah, attendance link will be shared with you just in few minutes. Okay. So in your chat window, you can find them in couple of minutes. I'll try to share the link. So those measurements like F1 score, and then you have something called as sensitivity, okay, specificity, then precision. Like this, you have different measurements. So these measurements will help us understand how good is our model with respect to prediction of 0. How good is our model with respect to prediction of 1? Then how good is our model in balancing your precision and sensitivity? You can call that as a F1 score. So further knowledge we can get about the model through these measurements and all. So far we have talked about your accuracy of our logistic regression model, machine learning model. We have talked about the accuracy. Now, we can get more information about the model. Like for example, you can use in Python, there is a function called classification underscore report. So what I can do, I can say from sklearn.metrics import classification underscore report. And then I can apply this function on my actual value, predicted value. So classification underscore report, apply it on your actual value and predicted value. So what is going to happen? It is going to give us information about different measurements. For example, it is going to tell us about recall. So I'll give you one simple definition of recall. Recall is also called as sensitivity. So it can give us information about how good your model is able to predict 1. So how good is your model when it comes to predicting category 1? You can understand it from this measurement called as recall or sensitivity. That is called as recall. So now, for example, if you observe this value, what you are able to get is 78%. That means your model is having an accuracy of 78% when it comes to predicting category 1. So how good is your model when it comes to predicting 1? That information you can get from your recall or sensitivity. Now similarly, what about 0? Your model is having around 65% accuracy when it comes to predicting your 0 category. So what we can say, your model is much better when it comes to predicting 1 compared to predicting zeros. That is the understanding what you are able to get from recall. So more information. Apart from accuracy, how good is your model in predicting 1? How good is your model in predicting 0? What is the recall value you can understand through this measurement of sensitivity. So remember these points, what we have discussed so far in our session today. So we have talked about building our model, logistic regression model. We have seen the steps and all, how we have compared your actual values with your predicted values. And we started evaluating this model's performance by measuring accuracy. And we started talking about a classification report. We started talking about recall. How I can use recall and understand what is the accuracy of the model when it comes to predicting 1 and when it comes to predicting zeros. You can understand how good is your model. So that is the idea. Now we can break for the day here in our discussion and then continue again. We try to understand this model and we talk about other machine learning models, deep learning models, what you can use on this data in our next session. So thanks for your time today and take care and see you next week.